Expanse of some standard functions e power x 1 plus x by 1 factorial plus x square 2 factorial plus e power minus x 1 minus x by this kind of expansions in some cases will be used to find the limits. Sinus of x plus x cube with 3 factor plus 9 x power 5 by 5 factorial. Cosinus of x pi by 2 minus sinus of x, that is this value x plus x cubed by 3 factorial plus 9 x power 5 by 5 factorial. Tangents of x or cosinus, okay, x minus x cubed by 3 plus x power 5 minus etc. 1 plus x whole power n 1 plus nx n into n minus 1 by 2 factorial evolution of limits by El Hospital rule. This result states that if limit extends to a f of x by g of x reduces to 0 by 0 or infinity by infinity, so this rule applicable only for these two forms, 0 by 0 or infinity by infinity form only. Then differentiate both numerator until and unless this form is removed. That is, limit x tends to a equal to into f of x by g of x equal to limit x tends to a f dash of x by g dash of x provided the latter limit exists. But if it again take the form 0 by 0 or infinity by infinity, then limit x tends to a f of x by g of x equal to limit x tends to a f dash of x by g dash of x limit x tends to a f double dash of x by g double dash of x, and this process continued till 0 by 0 or infinity by infinity form is removed. Evaluate limit x tends to 0 a per x minus b per x by x. Limit x tends to 0 a per x minus b per x by x. If you apply 0, a per 0 1, 1 minus 1, 0 by 0 form equal to limits x tends 0 a per x log a minus b per x log b by 1. Differentiate numerator alone and differentiate denominator alone. Differentiate x1 for this a per x log a, b per x log b. Log a by log a by b, log a minus log b, that is log a by b. Some standard units. Standard limits. Limits x tends to 0 sin x by x equal to 1. Limit x tends to 0 x by sin x equal to 1. Limit x tends to 0 sin x equal to 0. Limit x tends 0 cos x equal to limit x tends 0 1 by cos x equal to 1. Limit x tends 0 tan x by x equal to limit x tends 0 x by tan x equal to 1. Limit x tends 0 tan x equal to 0. Limit x tends to 0 Sin inverse of x by x equal to limit x tends to 0 x by sin inverse of x equal to 1. Limit x tends to 0 tan inverse of x by x equal to limit x tends to 0 x by tan inverse of x equal to 1. Limit x tends to infinity 1 plus a by x whole power x equal to limit x tends to 0 1 plus ax whole power 1 by x equal to x tends 1 plus a by x power x tends 0 1 plus ax whole power 1 by x equal to e power a. Limit x tends to 0 a per x minus 1 by x log a to the base a is greater than 0. Limit x tends to 0 e power x minus 1 by x equal to 1. Limit x tends to a x power n minus a power n by x minus a equal to n into a power n minus 1. Limit x tends to 0 log 1 plus x by x equal to 1. Limit x tends to 0 1 plus x whole power 1 minus 1 by x equal to n. Limit x tends to infinity sin x by x limit x tends to infinity cos x by x equal to 0. limit x tends to infinity 1 by x equal to 0. Limit x tends to infinity a power x 0 modulus less than 1 if a equal to 1, infinity if a is greater than 1. Does not exist if a less than equal to minus 1. Limit x tends to a f of x power g of x equal to e per limit x tends to a g of x into f of x minus 1. Some limits which do not exist limit x tends to 0 1 by x limit x tends to 0 x power 1 by x limit x tends to 0 modulus x by x limit x tends to a modulus x minus a by x minus a. Limit x tends to 0 sin 1 by x limit x tends to 0 cos 1 by x limit x tends to 0 e power 1 by x limit x tends to infinity sin x limit x tends to infinity cos x an important result. If m comma n are positive integers and a0 comma b0 not equal to 0, and non-zero real numbers, then limit extends to infinity, a naught x power m a1 x power m minus 1 plus etc. A m minus 1 x plus a m divided by b naught x power 1 b1 x power n minus etc. b n minus 1 x plus bn equal to 0. M is less than n. That means degree of numerator is less than degree of denominator. If the degree of numerator denominator are equal, answer a naught by b naught, this value. Infinity, m is greater than when a naught b naught is greater than 0. Minus infinity, m is greater than n, then a naught b naught is less than 0. It's very, very important result. Evaluate limit extends to infinity ax square plus b by x plus 1 when a greater than 0. So degree of numerator is greater than degree of denominator. When a is greater than 0, limit x tends to infinity ax squared plus b by x plus 1 equal to infinity. When a not equal to 0. When a equal to 0, limit x tends to infinity ax square plus b by x plus 1 equal to 0. If a equal to 0, degree is less than denominator. The answer is 0. Therefore, limit x tends to infinity ax square plus b by x plus 1 equal to infinity. A is greater than 0. 0, a is equal to 0. If limit x tends to infinity x square plus 1 by x plus 1 minus ax minus b equal to 0, find the value of a and b. So limit x tends to infinity x squared plus 1 minus ax squared minus ax minus bx minus b divided by x plus 1 equal to 0. Limit x tends to infinity x squared into 1 minus a minus of a plus b into x plus 1 minus b by x plus 1 equal to 0. Which limit equal to 0, which means that degree of numerator is less than degree of denominator. So degree of denominator is 1. Therefore, degree of numerator should be 0 for that, which means this should be 0, this should be 0. So 1 minus a equal to 0, a plus b are equal to 0, a equal to 1, b equal to minus a equal to minus 1. If limits x tends to infinity x square plus 1 by x plus 1 minus ax minus b equal to 2, find the values of a and b. Limit x tends to infinity, x square plus 1 minus ax square minus ax minus bx minus b whole divided by x plus 1 equal to 2. Limit x tends to infinity, 1 minus a into x square minus of a plus b into x plus 1 minus c by x plus 1 2. This is a finite limit. The only possibility is degree of since limit is 2, degree of numerator equal to degree of denominator. Here 1, therefore it should be 1. Therefore 1 minus a equal to 0, which implies a equal to 1. Therefore limits x tends to infinity, if a equal to 1, minus 1 minus bx plus 1 minus c by x plus 1 2 equal to minus 1 plus 1. Limit x tends to infinity, minus of 1 plus b into x plus 1 plus b by x plus 1 equal to 2. So a naught by b naught equal to, a naught means coefficient of x, minus of 1 plus by 1 equal to 2. 1 plus b equal to minus 2, b equal to minus 3. Therefore a equal to 1, b equal to minus 3. If limit x tends to infinity, x square plus 1 by x plus 1 minus ax minus b equal to infinity, find A and B. Limits x tends to infinity, x square plus 1 minus ax squared minus ax minus bx minus b by x plus 1 equal to infinity. Limits x tends to infinity, 1 minus a into x squared minus of a plus b into x plus 1 minus c by equal to infinity. So in this case, the limit is infinity. Degree of numerator is greater than degree of denominator. Therefore, 1 minus a not equal to 0, a not equal to 1. Since plus infinity, we must have coefficient of this term and coefficient of this term should be positive. Here we have 1. This quantity should be also 1. To be, this is positive. This should be positive. To make this one positive, a should be negative. If a is less than, this will become positive. So a less than 1, a not equal to 1, b can take any value. Continuity of a function at a point. For examining continuity of a function at a point, we find its limits and value at that point. if these two exist and are equal, then the function is continuous at that point. Mathematically, a function f of x is said to be continuous at a point x equal to a if f of a exists limit x tends to a, f of x exists on finite that is limit x tends to a plus f of x equal to limit x tends to a minus f of x equal to a finite number limit x tends to a f of x equal to f of a. Thus, function continuous at x equal to a. If limit x tends to a plus f of x equal to limit x tends to a minus f of x equal to f of a, that is a function continuous if RHL equal to LHL equal to value of the function at x equal to a. Continuity from left and right at a point. Function f of x is said to be left continuous at x equal to a if limit x tends to a minus f of x equal to f of a. Right continuous at x equal to a extends to a plus f of x equal to f of a. A function continuous at the point x equal to a if it is left continuous as well as right continuous at x equal to a. So, we will discuss remaining concept in the next session. Thank you.